This conference will now be recorded.
Fine, guys. So I think there are a couple of people who are pinging me for the e-library related deployment issue, right? What we will do is probably in the second half of the session today. Anyway, I'll start with that topic on the engineering, right? There I will again will tell you what to do to make sure that your e-library works properly. Okay, so we will cover that at the end, and if and then you try out those changes. If you still have a problem, we will probably take some time tomorrow before the session. Let's join a little early and then I'll sort it out, or even in the morning time of Indian IST, we can connect and then quickly sort out the problem, whatever you have it. Okay, so don't worry, we will get it done by tomorrow before the session starts. Whoever is having a problem, okay. Um, yeah, fine. So today, what is the plan is we'll get started with the basics of JVM, basics of Java, few hands-on in Java programs for you to get comfortable with the terminologies with respect to the way the developer is going to create the programs, compiling it, deploying it. So for you to uh, get into that space, will spend first 1 hour on that. Okay, it's very important because though it is not related to engineering, as I said last week, when you talk to developers um, about the response time issue, memory issue, you're going to talk about class, method, functions, thread, object, all these terminologies, right? So it should not be a black box for you. You should be able to talk to them with a certain level of conviction, okay, with a certain level of confidence. Okay, so that is very important. Okay, and uh, don't even think that it is something you will be able to do it or not, because we always feel a little bit of reluctant to go and talk to developers, thinking that they will ask something, they might be challenging your observations, right? uh, Not only you, everybody, even with the seniors, experienced people, the analysis will always have a two side of it. One, it might be correct, one, it might be wrong. Okay, that's how the analysis works. Root cause analysis, even with the production issues, it's very important to analyze it. Don't even think that it is always going to be correct or not. Okay, that's the kind of mindset you have. It you have that open mindset to look into the problems, analyze it, and provide your observations. Okay, so let's get started. um, okay, so before going to the Java basics, right? Java is something you need to install it in your machine. Okay, you go and install the JDK from your Oracle website. uh, so there are terminologies like JDK, JVM, JRE. You might be hearing this in multiple places. um, so the difference is, probably if you guys have worked on LoadRunner for an example, right? You have multiple components, right? Either you have a complete suite which will cover your fusion, analysis, load generator, controller, everything combined is a one complete LoadRunner suite, correct? But if you want to do only execution, you just need a load generator and controller, right? Or if you want to do everything, then you need all these components. If you want to do only scripting, you just need a Vusion, correct? Similarly, in Java programming, or using the Java applications, right? There are two aspects. One, you're going to develop something, debug something. Second is you're going to use a Java based application, right? There are two side of it. So if you wanted to debug, if you wanted to develop some code, compile it, and then create those jar or var, you need a complete Java development kit. JDK will have everything. JDK will consist of the libraries for development. It will have the Java runtime environment for execution, and JVM is your the Java virtual machine in which your code is going to get executed. Okay, so JDK is entire thing. When I say entire thing, right, it is as simple as, if you go to the your Java folder, Okay, if you go to the C and then program files and Java, okay, you have JDK, right? Within JDK, you have this library, JRE, bin, everything. If I go to bin, it will have all these utilities like JConsole, JMap, JStack. All these are all more of a monitoring, debugging tools. Along with that, you will also have the java.exe. Okay, so JDK will have all the libraries for development. It will also have your JRE, which is a Java runtime environment, important for starting any Java based application. Okay, for example, if you wanted to open a Jmeter, okay, in your mission, you need Java. Okay, but for that, you don't need entire JDK, you just need a JRE. Okay, if you want to open Eclipse and then compile some programs, write some programs, you need entire JDK. Okay, so JDK is a superset which will include both libraries for development and also Java runtime environment and JVM. Okay, we'll look into the JVM as we go into the session today, but that's how this is organized. Okay, so better you install the entire JDK. If you go to Oracle website and then maybe in the Google, right, just go and search for Java JDK 8 and then install it. It's a very simple installation. It will just a couple of next, it will get installed. Okay, and then just go to the environmental variables. Okay, after you install Java, sometimes the this variables will be set automatically when you install it. Sometimes you may have to do it manually. Okay, so go to this environmental variables, and then in Java again, when you say e-library application is not working and all, right, these small things you have to make sure that it is correct. Okay, so you have to add a variable called Java. Okay, and if I open this, it will be Java, and then provide your bin path up to the bin slash bin. Okay, and for Java om, give up to the JDK. Okay, Java up to bin, Java om up to JDK. Okay, these two variables you add it and provide the path. Okay, and then there will be already a variable called path. Open this path. Okay, here as well, you have this JDK slash bin. You type, you click new, and then uh, paste your path, and then you should find this the entire bin folder in the path as well. Okay, so three things you do it. Once you're done, say okay, and open a new command prompt, and then type in Java hyphen version. Okay, so you will find the Java version, whichever that is configured in the environmental variables. You should see it now, which means you're good with the your setup in your machine for Java. Okay, you can do this maybe later tomorrow or on Monday, Tuesday, to make sure that you have your environment proper. Okay, or even you can try it out tomorrow morning also, so that if you have any problem, we can clarify tomorrow itself. Okay, so this is a very prerequisite to be available in your mission for doing any kind of debugging, analysis, opening the tools. For this is very important. Okay, and that's a very simple explanation of JDK, JVM, and JRE. JVM is something very important for us, because that is where you are going to your application is going to get executed. It is going to occupy, it is going to consume memory, it is going to consume CPU. So we will look into those JVM architecture as a next topic today. Okay, maybe after 30-45 minutes we'll go into it. Okay, now um, the Java, from a Java programming basics. Okay, uh, we don't want to go and learn Java because we're not going to develop something. We're not going to develop an application here, right? So we don't want to go and take a book for Java and then go into topic by topic, looking into the your OOPS concept, data structures, and then all the usual topics that will be there in any Java book, right? It is not necessary for us to go and look and do that kind of a learning. Couple of reasons: because we will not have time, we will not have motivation to go theoretically, and we are not going to do a development anyway. We want to understand Java in such a way that we'll be able to relate that when we go and do the performance engineering. Okay, so we'll try to understand this Java program in more of a skeleton way. Okay, when I say skeleton, any program in an application, right, in a Java application, it can be a small application or a big application, enterprise wide application. It's everything is going to have a kind of a template. Okay, for example, in LoadRunner, you have user init, you have action, you have end, you will have start transaction, end transaction, runtime settings, you will have your parameterization, all these things, correct? Similarly, but we never would have questioned or thought about what is there in init, what is there in action, um, what is there inside your start transaction, end transaction. We never know, right? It's all, we just go and create script, use those inbuilt functions. It's more, again, more of a templated way, right? Similarly in Java also, we'll just keep it very simple. Any Java program is going to have these things. Okay, it's going to have a class, object, method, package, import, and data type. Okay, so class, you open up, you create a program. A program is going to be, say, a simple calculator. A plus B is equal to C, right? So and then you save that program, and you will name it as a .java. Okay, all the programs in Java, you will save it as a .java, and when you compile it, it becomes .class. So class is a program, class is a compiled version of a Java program. Okay, so one application will have multiple class file: login, search, registration, checkout. So there is going to be n number of Java programs in any application. Okay, so class is a compiled version of a program. Okay, let me also open the Eclipse so that I can show you the structure of the programs as well. You can also download Eclipse from the internet, or I'll upload this Eclipse also to the drive to make it simple. Okay, let it open anyway. Fine. So class, right? So in the class, you will have two main things. One, the algorithm for your program. Algorithm could be addition, it could be a subtraction, it could be a division, right? So you will have a every algorithm or the actual processing will be written inside a method. For addition, I'll be having a addition method. For subtraction, I'll have a subtraction method. Inside the addition method, I'll have the actual calculation. Calculation could be a plus b is equal to c, or a minus b is equal to d, or connecting to a database could be a processing, or reading a file and writing it could be a algorithm. So any actual processing will happen inside a method. So inside a class file, you'll have multiple methods. See, we have a program. Why we are writing a program? It has to receive an input, it has to process it, it has to save it and provide an output. That's the simple need of any program, right? So in a Java program, you will have a multiple methods which can do a processing. Okay, and to receive the input and to write into an output, you need data, right? You need to declare some variables. Okay, so if I want to do a plus b is equal to c, I want to declare a, I have to declare b, I have to declare c. A can be an integer, b can be an integer, or if you want to store some text, it can be a strings, arrays. So there are going to be data type in Java, which can be integer, string, array, all these things. There are two types of data types. Okay, primitive and non-primitive. Okay, if you guys really don't understand this as well, don't worry. All these things, when we are going to do an engineering, you will be able to relate it. Okay, so initial 15-20 minutes, or at least today partially it might be a little theoretical, but you need these concepts so that when you go into engineering, you will be able to understand, or it won't be a black box for you. Okay, so data types are primitive and non-primitive. Okay, the reason they have splitted into primitive and non-primitive are very much related to our performance, the memory management. We will learn it in the upcoming session when we go to memory. Okay, all the small variables, integer, byte, boolean, character, and all, which will occupy lesser memory. Okay, that is what we call it as a primitive. Again, remember, these things are all performance related. Okay, primitive, non-primitive, it is divided, data type divided into primitive or non-primitive. Small variables are called primitive, which are int, byte, character, boolean. The things which are going to occupy more memory, like your strings, arrays, objects, all are non-primitive. Okay, um, that's how the internally JVM is going to handle these declaration from a storage perspective. You will learn a lot about these things in the probably next week when we go into the memory leaks and memory related topics. Okay, so any program is going to have this integer, byte, character, or strings, arrays, and it's going to have multiple methods which is actually going to do some calculation. Guys, you able to see the screen?
Yes.
Yes, sir.
Okay, because my network came in and went out, I don't know whether it's still getting shared, so I thought of checking with you. You could able to see the screen of Java programming basics, right?
Yes, we can.
Okay, great. Okay, sure, fine. Now, application can have multiple classes. I told you, right? It can have login, it can have search, it can have checkout, it can have registration. So combination of multiple class files, it will be grouped under a package. Okay, so package is nothing but a group of class files. Okay, and then you have something called object. Okay, so the name of object, definition of object, you might have heard a lot of definitions, lot of people might have explained you in a different way. I don't want to give a perfect definition for this. Okay, because perfect definition will always going to be a little bit confusing. I will try to explain you with an example. Okay, try to understand this. You have amazon.com, okay, website, and you open the amazon.com, and then go and search for a, say, laptop. I From my laptop, sorry, I am also going to open my amazon.com. I'm going to look for a mobile. Okay, so you're going to search for you want to look for a product, Lenovo laptop. I'm going to look for a product for say some Samsung mobile. Okay, and then you click on your price calculation, or the cost of the product. I also do the click on the cost of the product. Okay, so when I do, we both are doing the same operation, right? We wanted to know the price of the product. Okay, but you are doing it something from your mission. I'm doing it from somewhere from my mission. Both will go into the Amazon application server, correct? Both will hit the Amazon application server for the same functionality. Okay, so there will be a class file for calculating the price. Okay, and the program will temporarily store the product name, the quantity, and then it will do a calculation, and then it will send the output to you and also output to me. Okay, so at the runtime, what will happen is your JVM will create a instance of your program, instance of your class, a duplicate copy of your class into the memory. Okay, so object is a duplicate of a class file. There's going to be only one class file called price calculation. Okay, so the instance of that, a duplicate of the class file will be loaded in the memory for you separately and for me separately. So one class file, there will be two objects will be created, one for you, one for me. That object will store your product as laptop, and my object will have the product as Samsung. And then for you, the algorithm will get executed, and then the output will be stored temporarily for the laptop price, and for me the price of the mobile. And then it will be sent to you the final output, and I'll also receive the final output. After some time, both these objects will get deleted from the memory. Okay, um, the deletion of the memory and all, it's more related to the garbage collections, which we will learn later. We go into the other topics, but that's how the cycle going to work, right? So object is nothing but a duplicate copy of a class file, or an instance of a class file, that is going to created during the runtime. Which means if there are 100 people who are going to access Amazon.com and going to look for the price calculation, right? 100 objects will be created. Okay, for every functionality, such objects will be created in the runtime, and it will be deleted in the runtime. Okay, so object is nothing but a duplicate of a class file. Okay, so you understand this at this level. Okay, let's not go into the more technical, more exact definition of that as per Java book. That's not required for us. Okay, this definition is important because we are going to do a memory leak analysis, we are going to do a heap dump later. That time you should know what we mean by object. Okay, for that this definition will be very very useful for you to understand this better. Okay, so any program is going to have a class, object, method, package is nothing but a group of class files. A class file, one class file will have multiple methods, it will have multiple data declaration. Okay, and like one class, there are going to be multiple classes. Classes combined is called package. Okay, for example, if I go to my Eclipse and the e library application, okay, whatever we are using it, right? The code for that, if you look into it, if you go to the Java resources, if you go to the source, there are three packages: com.java.tpoint.beans, com.java.tpoint.davo, com.java.tpoint.servlet. If I go expand it, there are going to be multiple classes: add book, add librarian, admin login, edit librarian, return book. All these are all functionalities, right? So every functionality will have a dot Java. Everything is a program. Okay, so when we compile it, it becomes a class file. So you have a admin login class file, you have a add librarian class file, you have a add book class file. Okay, so every application will have multiple classes grouped under a package, a logical grouping of a class files. And inside your each class file, there will be methods, and there will be a uh, uh, variables that will be declared like a string, right? Integer strings that will be declared inside the program. And when you look into this, something called one more thing what we see is a import. Okay, import means we no need to write programs everything by ourselves. There are going to be reusable programs written by your own teams, by other teams in your organization, or you can download a lot of reusable programs from the internet also. Okay, so to read a CSV file, to read a JSON file, to connect to a MySQL DB, all these things you no need to write the code by yourself. There will be programs available in the open source community, where from where you will download and use it. So all those things are all called import. Okay, so if I go to something, for example, database.java, will be importing java.sql.connection, SQL driver manager, right? All these things are all imports. So imports are nothing but importing other people's other projects reusable packages, so that you can use those classes methods that is available in the uh, reusable package. Okay, so from a structure of the program, this is how the structure is going to be. Okay, it's going to have a class, object, method, package, import, and data types. A simple program, or if you have a web application like e-library also, the structure is going to be same. It's not going to change at all. Okay, to that level is what we need to understand the Java program for our need. And if you are really interested to go further, okay, and to learn Java a little bit more, okay, again, do a reverse engineering way of learning. Don't go by book, because we don't have time. We will get easily demotivated when we go to theoretical learning. Okay, so always go to practical learning, write programs, and try to understand why it is written such a way. Okay, you can create yourself the requirement, like reading a CSV file, writing into a JSON, parsing a JSON file, or connecting to a database, making a connection to an HTTP URL. So you can create these small requirement, and then you can go and look into the Google, or now with the help of Copilot, or with the your ChatGPT and all. If you go and ask the question, okay, it will give you the program to you. Okay, for example, right, if you go, if I have this Copilot with me, if I go and ask, again, this is something we are going to use it as a assistance. Okay, definitely it's not going to help you to do everything, but if you ask a proper question, it is going to help you out. For example, if I ask, provide me the code, Java code, to read CSV file, it will give the code. Okay, and then take this code, put it in the Eclipse, and then compile it and execute it, and then go and try to learn why these programs are written like this, what is buffer reader, what this line is doing, what this line is doing. So if you're interested, you can go by this way of learning the Java, not by book. Okay, once you do this, then you can probably go back to the book, and then probably try to understand a little bit more about buffer reader. Okay, more about strings, more about why this is public static void. Okay, don't do that other way around, theoretical to practical. We will lose definitely our interest. Okay, um, okay, what we'll do is, next 15-20 minutes, we'll try to write some programs. Okay, again, the intention here is to not to go develop applications. Even you people don't even think that whether you will be able to do it or not. It's very simple. We are not going to do any complicated algorithms here. Very simple calculations, simple logics only. Okay, you can also do it. You better do it, because it will give you, once you do this hands on, you'll get more confidence. Okay, um, open the Eclipse. You can download it from the internet again. Okay, Eclipse version, anything, any version should be okay. I mean, or I'll do one thing, for to make you simple, I'll upload this Eclipse directory, the zip file, to the drive. Okay, let me go and do this right away. Okay, if you go to the this p August folder, under the Java sample, in the Java sample, you will have a lot of Java programs. Okay, which I will look into it now as well, which I will show it to you now. We'll do this now. I'll upload this zip file, which you can download. Okay, let it get uploaded. Um, Fine. Now, what you do is once you open this Eclipse, go to File and then say New. It got stuck. A couple of seconds, please. Okay. No, I'll go to New. Okay, and the new, go and create a new project. Okay, the new project, you select a Java. Okay, Java project, and then say next. Okay, and then you just go with the project name. You can say that learn Java. Next, finish it. Okay, and just say no. Fine, so you'll get a new project created here. You'll get a structure like this: JRE library and source. Now what you do is right click it and then go to new and then create a new class file. Okay, so in the class file you can learn whatever you want. You say hello world. Okay, and then you select this option. Don't worry why we need to select, I'll tell you later. Okay, just select this public static void main also, and then say finish. Okay, and then to check whether your Eclipse works, whether your JDK is uh, configured properly, what you do is just put the print statement. Okay, nothing more than that. Okay, system.out.print.ln, save it, and then right click and then run as Java application. Okay, it says it is printing whatever that is there in the print statement. This is very simple way to make sure that your Eclipse is installed properly. It could able to compile it, it could able to execute it. Okay, so this check you do it at the beginning to ensure that your Eclipse is working fine. Okay, and then um, let's take a couple of examples. Okay, first we'll do a very simple one class file. Okay, and then we'll do a say addition. Okay, I'll say new, again a class file, or to save the time, what I'll do is I'll go to this package, my already existing package. I'll go to this program. Okay, so in this program, don't worry about the lines that are commented. Okay, I have just 4 lines of code, right? I'm declaring a integer value is equal to 12, integer value is equal to 10, and then I'm adding value 1 plus value 2 and storing it in something called sum, and then I'm printing it. So addition of two numbers, I'm declaring two um, integer, two primitive data type, and then I'm doing a calculation, and then I'm printing it. Okay, it's a very simple addition. I'm doing it in a program, one single program. Okay, I'll save it and then I will run this. Okay, it says that sum is 22. Okay, now this is only one program and I'm doing an addition. Now say for example, you're going to have in an application, I said that you're going to have multiple class files, right? So I have, say I have two class files. I'm going to create a a separate class file for doing all these calculation. Okay, I'll go to the second program.java. I'll rename this. I'll do one thing. Okay, let it be a second program itself. Okay, second program is where all my addition, subtraction, multiplications are going to be there. Okay, and then from my first program, in the first program, I'll have only the inputs, and I will call the second program for doing addition, calculation, or division or multiplication. Assume that second program is a calculator program. Okay, and my from first program, okay, I'm going to call the second program to do an addition and get output, to do a subtraction and get output. Okay, so for that, what I have to do is to call any other program. I cannot call it directly. I have to create a object. I have to create a duplicate of that. Okay, that's how Java works. From one class file, if you want to call the second class method, in the second class, I have a method called addition. I have a method called subtraction. I have a method called multiplication. Okay, to call these methods, to call multiply method, to call addition method, to call subtraction method, I have to create a instance of this class file in my first program. So I have to, I'll take this out. I will create a instance of the second program. This is the code for creating an instance. I'm creating an object called my object. Okay, and then I'm creating a duplicate of the second program. Okay, so in the runtime, whoever is going to call the whoever is going to call this first program for addition and subtraction, every time a new object will be created for the second program. Okay, and inside that, what I'll do is I'll use this object, my object dot, I can do addition, I can do subtraction, I can do multiplication, multiply. All the methods that is there in the second method, I can call it. So I will use this my object, my obj. So I can keep whatever name I want. I can say this as a calculation object. I can name whatever object name I want. Okay, so then what I will do is calculation j dot, all these things will come. Okay, this is the object name. Whatever name you want, you can give it. I'll go back to my object. Okay, I'll just comment this initial addition because we are going to call the other programs addition file. Okay, yeah, now okay, so I'll call the, I'm creating an object, and then I'm calling the my object dot add and passing this value 1 and value 2 here, and then I'm going to save that in the sum. Similarly for subtraction, if you want to do a subtraction, I will do the int difference of my object dot sub of value 1 comma value 2. Okay, so this time what I will do, I'll just call the other programs method, pass the value, and then I'll save it. Inside the second program, I'm going to have a method for addition. The actual algorithm is here: value 1 plus value 2, value 1 minus value 2, value 1 into value 2. All these things are going to be in the second program only. Okay, so the first program will call the second program, will pass on the required data, and second program is going to do a calculation. Okay, so which means what you have to understand here is, in an application, you're going to have a multiple class file. From one class file, you will call another class file through an object, and the second class file can call the third class file. So there will be multiple flow of your functionality, flow of a control. From class 1 it will go to class 2, class 2 it will go to class 3, and then from there it might go to database, it will call a database, and from there it can call a third party services. That's how every application is going to work. For example, in Amazon.com, right, for doing a price calculation, initially it will go and call a, say, it will go and check a inventory, whether the inventory is available or not. It will call a inventory.class file, and then it will go and check the discounts. It might call a discount program to get a discount, and then to calculate the tax rate. If you are from India or if you are from UK, it might call another class file for tax calculation. So for a price calculation, it will call inventory.class, it might call a discount.class, and then it will call tax.class. And internally, these class might call do a call to a database, it might call to a third party services. So for a single, from a UI perspective, you just click a button, right? Calculate my price. But when it comes to application, it is just not one program. It is going to be a series of sequence of programs. Okay. So when you're going to analyze a response time problem, when you're going to analyze a memory problem, your response time issue can be in the first class file, it can be in the second class file, it can be in the third class file, or it can be in the database query, it can be in the third party calls. Great. So whenever you're going to do an analysis in your JProfiler or AppDynamics, that's how the tool is going to provide you the root cause analysis. It will say the third class file or a fourth class file or the particular method or a DB query is taking time. Okay, so this entire journey is what you will have to analyze, from where it started, from where and all the call went, and where the response time was high. Okay, so for that, when you do that kind of analysis, you should be able to visualize that how it is going to be within the application. That's the reason I'm explaining these kind of programs. Okay, so when you write these kind of programs by yourself, you will know that application will have multiple class files. From one class file, you will be calling another class file through an object. Okay, and then this in turn can do another DB call also. Okay, that's how any structure of a program is going to work. Okay, now if I go and execute it, I'll go to my first program.java. I'll go and execute this. I'm here. I'm start of the second program method. 22 and 2. So 10 plus 12 is equal to 22, and 10 minus 22, 10 minus 12 is equal to 2. Okay, so it is going to do a difference of this and then addition of this. If I do a multiplication of this, then what I will do is I will say int multi value is equal to obj dot my obj dot multiplication value 1 comma value 2, and then I will print that as well. I think printing will be there anyway in the second. If I go and execute this, so all three, sum, addition and multiplication will be, some difference and multiplication will be done. Yeah, 120. Okay, so that's how when two program is going to work together. In every application, you will have logic written in every in single class file, and you will be calling one class file from another class files. Okay. Similarly, I can go and create multiple programs like this. Okay, let me show another example for you. We were talking about this price and calculation, right? Say for example, I have a class file called price.java. Okay, so here I have a method called price calculator. It is going to do a simple um, cost into quantity. Okay, cost into quantity, it is going to multiply in a real time. Say in Amazon, Flipkart and all, it will go and do a tax calculation, it will go and do a discount, it will apply a discount, and it will go to the database to get the price details, or depending upon the configuration, depending upon your model, depending upon the size of the screen, it is going to fetch the cost and it's going to do this price calculation. It's going to be a complicated algorithm, but it's still an algorithm. Here I have a very one line of cost into quality. There it might have a 30 lines including all these algorithms. But a method is a method. Inside a method, there's going to be an algorithm. Okay, so here I have a price calculation. It is going to, I have hard coded a cost as 2000 rupees instead of getting it from a DB. For the laptop, for mobile, I have given it as a 300 rupees or USD, whatever it is. Okay, and I'm going to do multiply cost into quantity. This is the second program, price calculation program. And there's something called card.java. Okay, so this program is what it is going to be called initially from a UI. When you type in you select a laptop, you select a quantity, and then do a price calculation. It will come to this program, and from UI, the data will come, like it mobile or quantity. It will come from there. It will get saved. I have hard coded here for since it's a standalone program, but ideally this data will come from the UI, and then it will come into this method. Okay, and then this data will be passed in the object. So I'm creating an object for the price.java. I'm creating a, because I cannot call the price method directly, right? So I have to create an instance of the price calculation. So I've created a my price obj price new price one, and with that I'm calling the price calculation by passing the product and quantity. Okay, so from first program I am passing the product name and quantity and calling the second program. And second program, it will do a actual calculation. Okay, if I go and execute this, it will go and calculate product is mobile, product is quantity is 10, and then it will print price is 3000 rupees, because mobile is 300 rupees. 300 into 10, 3000. If you go and give as a laptop, okay, then execute it, it should print 20,000. Yeah, because one laptop is 2000 rupees is what you're given. So 20,000 rupees. Okay, so that's how you can visualize in real time. Also, you're going to have such multiple programs, one program calling another program through an object. It is going to do all these calculation. Okay, um, so if you wanted to practice programs, as I said, you create a simple program and you define your own logic, your own requirement. You may have to do a database connection. You may have to do a probably connect to a HTTP URL. You create your own requirement and then go and search that algorithm from Google or from Copilot. Okay, and then copy the code, put it here, execute it. It will execute definitely. Okay, you might get some errors, but small programs like this requirement, right? It will work. Even if it's not working, that's okay, but you will get an answer on. Okay, so I have a sample program for connecting to a database, making an HTTP connection. All these things are all available in the this Java sample repository. Okay, you can download, you can use it, or you can at least look into it. But idea of this is to not to make you as a developer, but to understand the concepts, understand what a developer is going to do. A developer is going to do this kind of work only, right? He will create a package, he will create a classes, he will create objects, he will compile it, and this is what is going to get deployed in the your as a jar or as a war. Okay, um, I'll pass it here. You might have a lot of questions. Don't worry. If you don't worry, if you don't understand few things, this is just to make you to come out of that any kind of a myth, whether you will be able to do it or not, right? So, and also to get that basics terminologies, you should be able to visualize this our program is going to be, our application is going to be, our class is going to be, our object is going to be, right? For that is the only purpose I'm explaining these things. So you also do this if you have time, if you're interested, do this. It will help you definitely. Okay, I'll take a pass here, guys. Anybody have anything that you wanted to ask? Maybe next 5 minutes. We'll spend some time, and then probably we'll take some 2 minutes, 2 to 3 minutes break before we continue. Anyone have any questions?
Uh, yeah, hi, Krish. Like, I just wanted to check, like, Java version does not matter. Like, any version we can have, right? JDK version.
Any version is okay, but you might find a problem with the Tomcat compatibility with the Java. So you just need to make sure that if you install Java 17 or 21, download a compatible Tomcat version. Okay. If you don't want to
And
have that kind of
ideally,
a,
what do you suggest, like 1.1,
ideally Java 1.8
like 8 version?
and Tomcat 8.5 or 9.5, which is there in my mission, which is compatible. But you can try with any combination. That is not a problem. But I would recommend to reduce the troubleshooting issues. You install Java 1.8, which is nothing but a Java 8, and Tomcat, whichever Tomcat I have uploaded in the drive, you can download and use it. Okay. Yeah. Again, others, again I'm saying, repeating this, don't think that okay, is it something Greek and Latin? No, you will be able to um, relate this when you go into the engineering sessions. Okay. Okay, fine. We'll probably take a 3-4 minutes break. Time is 8:27. We'll meet again by 8:31. 3-4 minutes. Okay, for a quick break. Fine, guys. I'm back. Hope you guys are also back. Again, anybody have any questions on whatever we saw the last 1 hour? Don't worry, guys. I mean, don't even think that whether the questions are going to be silly or not. We are here to learn. So don't hesitate. Please ask questions. Don't think about others, what they will think. Nobody knows others here. So don't even worry. I mean, uh, dare to ask questions. Um, whatever I know, I'll be able to explain that. Okay, no worries. Um, Quick check. You guys able to hear me?
Yes.
Okay, good.
Yes.
Okay, okay, great. You have any questions, guys?
No, Satish.
Okay, okay, fine. Ramesh, you're in. Okay, if you have any question, Ramesh.
Yeah. So, if classes for execution of class, right, a duplicate objects will create. Why we need objects when directly with class only we can get the output, right?
See in Java, see if you're going to have only one class file and everything is going to be there in a single class file, you no need to create an object. But if you have two classes, okay, see in the runtime, just think that multiple people are going to access it, right? You're going to access the same price calculation. I'm going to access it, and for you, the data variable is going to be laptop. For me, it is going to be mobile, right? So the data is going to be different, and which means the common program, whichever is going to get called, um, it should handle and execute for your requirement and for also more for my requirement, right? So for that, the instance of the duplicate of the class will be loaded, and then that object will be for you, and another object is going to be for me. So and that's how Java works, right? Why it is done in such a way, I don't want to again go into a technical aspect, but just think from this angle, from an end user angle. As I said, there's going to be one common program for price calculation, and concurrently you also will access it and I also will access it from a UI, and it has to handle your uh, order of laptop, and it has to handle my order of mobile, and it should do the calculation. So uh, at the runtime, it will create a duplicate of that class file and do the processing for you and separately for me.
Yes, Satish. I'm clear here.
Okay, okay, perfect.
Thanks.
Oh, yeah, no problem. Again, this is not a perfect answer. This is not a exact answer, but it is more. I want to make sure that you understand practically, but not more a bookish way of giving a definition. Okay, that's not required actually. Fine. Now, next 1 hour, what we'll do is, I'll go into the JVM basics, okay, um, and then we will go into the last 10-15 minutes. I'll spend time on these e-library application, uh, developer tool, certain things that is going to be required for us to get into the engineering topic. Okay, so yeah, so I'm talking about JDK, JRE, JVM, right? JVM is the Java virtual machine, which is going to actually handle your uh, execution of your classes, execution of your application. It's a Java virtual machine. Okay, so though you have a laptop, though you have a server, Java needs this virtual machine for execution. Okay, so the flow, if you see, you have .java, you have .class, and this will classes, all the classes will get loaded into the JVM, and then at the runtime this JVM is going to execute those classes and it is going to provide an output. Okay, so for the JVM, um, there are multiple components inside JVM. Okay, class loader, memory, and execution. Three major components. Okay, again, JVM is a Java virtual machine. So for Windows, you will have a separate JVM. For Linux, you will have a separate JVM, and for every OS, you're going to have a when you install Java, when you install JDK, corresponding JVM will get loaded in your machine, depending upon Linux or Windows. Okay, and then what will happen is all these classes, right? Application will have multiple classes. Okay, so when you start your Tomcat, or which means when you go to start your application server, all the classes has to be loaded into the memory. Okay, you might have 10 classes, 50 classes, 100 classes. All the classes will be loaded through this class loader. That's the first component. We'll not worry about it because it is not related to the performance at all. It's just a class loader as a component to load the class. Okay, second is going to be your memory. Okay, that's very important component from a performance perspective. Okay, so JVM memory, it's going to have multiple subcomponents in it. Okay, um, you have something called metaspace, heap, stack, PC register, and native method stack. Okay, uh, out of these five components, the heap and stack are more important from a performance engineering perspective. And out of these two, heap is the most important, because we are we have control over configuring the heap, tuning the heap parameters. There will be a problem with heap, there will be performance issue with the heap. We will analyze, we will profile, we will monitor, we'll do everything around this heap area. Okay, so that's why out of these five components, heap is very important. Okay, and second important is your stacks, JVM stack. We will learn a lot about this when you go into memory leak topic next week. But to keep it very simple, this heap and stack, nothing but, I was talking about this primitive and non-primitive, correct? All this primitive like integer, byte, character, boolean will be stored in the stack. So all these small variables which will occupy smaller memory will be stored in the JVM stack memory. All the strings, arrays, objects which is going to occupy more space is going to get stored in the heap. Okay, so to keep it very simple, you think that most of these um, uh, objects which are going to be big objects, strings, arrays, all these things are going to be stored in a section called heap. And then small data types, integer, character is going to get stored in the your stack. Okay, so in your laptop, if you're going to have a 8 GB memory, my laptop is an 8 GB RAM, and for my application, say e-library application, I will allocate say 2 GB or 1 GB to the heap. Heap alone, I will configure it. Other here I have given it as a method area. It's not method area anymore. It's called metaspace. So this metaspace, JVM stacks, PC register, and all, it will take the memory directly from my RAM. Heap, I will configure it. I need 2 GB. Other things together might require 500 MB or 1 GB. It will directly take it from my native memory. Native is nothing but from my RAM. Heap alone, I need to configure it 1 GB or 2 GB, because it's going to be a huge. Okay, so that's the difference between heap and stack. We will learn a lot about these things when we go into the memory leak and memory topic next week. But high level, the JVM architecture, it will have a class loader, and in JVM memory, you're going to have heap and stack. and you also have something called metaspace. Okay, metaspace will have the metadata about all your classes, a definition of the classes. Metadata means information about your class files. It's just going to have those definition of the class files, and throughout the application, uh, wherever you're going to declare a variable as a static variable, that is going to get stored in the metaspace. Okay, um, so you might have 10, 20, 30 static variable declared throughout your application. That is also going to get stored in the metaspace. PC register native method stack, let's not go into that. To keep it very simple, the registry will have a it's a register, right? It will keep noting down the information about what is getting executed currently, what threads are executing what lines of code. That registry is going to be there in the PC register. Nothing to do with performance, we will not worry about it. Same way for native method stack, your Java application might call your Windows application, your other Python programs, native programs in your machine. So whenever there's going to be a whenever it is going to call a native program apart from your application program, those informations are going to get stored in the native stack. Okay, so you no need to worry about PC register, native method stack, metaspace. We will not monitor, we will not tune or profile, so we'll not worry about these three components. But more from the architecture or component perspective, you just remember that these are the 5 subcomponents inside the your JVM memory. Heap and stack, we will learn a lot about it later when we go into the memory section. But at high level, heap is going to have all the non-primitive data type getting stored, like just strings, arrays, and objects. And, JVM stacks is going to store all your integer, character, boolean, small data declarations. Okay, and there is going to be a connection between heap and stack as well from a garbage collection perspective. So I'll not go into that level now. We'll park it for later. Okay, that's a JVM memory. And next is going to be your execution. Okay, so um, execution engine is going to have a couple of components. One is going to be your interpreter. Okay, so this interpreter will convert um, your bytecode, your Java compiled code, into your machine understandable code. My Java code I have to execute it in the Windows machine or in a Linux machine, right? So this interpreter will convert to your compiled code, will convert it your bytecode to a machine understandable code, machine understandable language. That's a role of interpreter. Okay, GC, garbage collection, is again another important component from a performance perspective, which is going to do a cleanup job. Cleanup job in sense, your heap is not going to have unlimited storage, right? It's going to have 2 GB, 3 GB, 4 GB, or whatever it is. So throughout a day, multiple objects are going to get created, multiple strings, arrays, everything is going to get created in the heap. So you cannot keep on storing it, right? It has to get deleted. Once you, as a user, when you do access amazon.com and you look for a price of a laptop, and then once your action is completed, that object has to get removed, right? Why it has to be there in the memory? Because it has completed the work. So garbage collection, collecting the garbage, collecting the unused object, is the duty of your garbage collector. Okay, so that is another important component which we'll learn in detail later. From a introduction architecture perspective, I'm explaining it. Okay, so interpreter is going to convert your bytecode to your machine understandable code. Garbage collection is going to be for your cleanup of your objects from the heap. And then you have a JIT compiler, hotspot profiler. This is more towards the performance, but we don't have a control. It's a JVM's internal working. Okay, it your hotspot profiler will keep looking into the frequently used methods and classes, and then it will pre-compile. It will see at a runtime only. It will convert the bytecode into a machine understandable code. So to improve the performance, the methods classes which are going to be frequently used, it will note down those method and it will pre-compile it. It is called just-in-time compiler. Okay, so instead of converting that bytecode to a machine code at a runtime, it will pre-compile and keep it ready. Okay, that's a work of hotspot profiler and JIT compiler. Okay, so all these components are going to be part of the execution engine. And out of these four, only garbage collection is something we, as a developer or as an architect or as a performance engineer, we have some control over modifying the behavior of garbage collection depending upon the need, depending upon the application behavior, depending upon the performance issue. We may have to fine tune the garbage collection. Okay, that will again we'll learn in the next week or next week. Okay, so overall you have class loader, JVM memory, which have multiple sub components, and then you have the third as a execution component. Okay, so this is going to be your JVM architecture. Okay, again quick comparison or just an understanding of jar and var, right? When you looking into this flow, you have .java, you have .class. Okay, any application is going to have multiple javas and multiple classes, correct? So once you create this program, you have to package it, right? You have to package it and deploy it, or package it and give it to other teams. So from when it comes to packaging it or when it comes to deploying it, you have to create a application, right? So the application is can be in a .jar or it can be .var. Yeah, you can jar is your when I go here, for example, if I want to go and let me open this. Okay, so what I will do is, if I want to, for example, this program, okay, allowed.java. Okay, if I wanted to make this application as a jar, right, I'll right click it and then export and then say that Java jar file. Next, browse. I'll give a destination for this. Finish it. Okay, so I have packaged this program into a jar file. Now if I give to this jar file to other teams, what they can do is they can just execute this from the command line, right? Java-jar. So it is printing the I'm here. Okay, so instead of I am running it my Eclipse, I have packaged it. And then I have created a jar file which I can give it to other teams, which they can actually use it in their own application also. If this jar file is going to be the reusable functions, they can also use it in their own programs and they can use those methods. Okay, so jar is one way of packaging your application. Okay, Just give me 1 second. Okay, fine. Now when it comes to your web application, right, you need to create something called WAR, web application archive. Okay, so this will include not only your classes, but also your HTML pages, your web pages. Okay, so when I go to my e-library application, you have this classes, you will also have this all the HTML file, JavaScript, style sheet, everything together, right? So you what you can do is you can right click on the source and then say export, and then instead of jar file, I'll create a war file. Next, and then I'll say e-library, and then I will go and save this. Okay, and then finish it. And this war file is what I will deploy it in my Tomcat. Whatever I give it to you, right, it's going to be a war file. Okay, so I'll be changing something in my admin login or view librarian. I'll be introducing response time issue or a memory issue, and then I'll save it and then compile it and then extract it as a war file, and that is what I'm going to give it to you in the drive. If you see the drive, and if you go to the each of the folder, if you go to the response time analysis folder, I will give you a if I go to this, you will have the war file, right, for response time analysis. Similarly, if I go to the memory, if you go to the memory folder, when we go into the memory topics, so the war file with memory issue, memory leak.war, I'll give it. Okay, so you have to download this war file, and then okay, you have to go to this, say I'll copy this war file. Okay, and then go to your Tomcat folder. This Tomcat folder, again, you can download it from the drive directly. Okay, so if you go to the here, and then in the Java sample itself, I'll upload the Tomcat also to keep it very simple. Okay, what I'll do is I'll go to this Tomcat, and then web apps, I will delete this, I'll delete this. Okay, and then paste it, and then I go to the bin. I will probably comment out. I think a few people have issues with the um, starting the Tomcat. Okay, the reason is I have given some folder directory in my mission. Okay, if you come here, okay, especially this Java 18.jar file, right? This is the AppDynamics configuration. If you don't have this path in your mission, it'll have a problem. Okay, so I'll also comment this out. Later you can remove the comment once you want to configure the AppDynamics and all. Later you can configure it. I'll tell you later when you go into the AppDynamics session and all. For now, I'll comment this out. Okay, so I'll save it. Okay, and then I will zip this. Okay, I will zip this. Okay, and then I'll copy this to the drive. Okay, use this one directly. Okay, extract it and download, extract, and then use this zip file. So is this Tomcat folder. Okay, so whenever I give a war file to you, okay, go to this and then go to web apps, copy this, go back, go to the bin, and they say cmd, say startup.bat, and then this will work. Okay, this will get started. Okay, once this is started, go to the localhost /e library. Okay, go to this 8082 /e library, and then admin@jtb.com admin123. Okay, and then say login. Okay, so the login should work with this war file. Okay, so this whatever tomcat I have uploaded, it will already have a war file in that. Okay, you can use that directly. Okay, whatever I uploaded here, it is uploaded now here into this folder. You can download, extract, and then war file is already there in the folder. You can just start it. This war file will not require a DB connection also. Okay, so I have removed the DB calls for login, so you no need the DB calls also. It should work directly. Just give me 1 second, let me check that. I'll turn off my MySQL. I'll just double check it whether SQL is required or not for login. For other transactions, you need MySQL DB. I'll tell how to configure the MySQL DB later. I don't want to confuse you with that. Okay, log out. So without your DB also, it should work. Yeah, it will work. Okay, in your mission, even if you don't have a MySQL DB, it will work. But after this, for view librarian or for add librarian, and then you can log in as a normal. So these things will not work since the DB is down. Okay, and then if I want to do a librarian login and all, this will not work. For that, you need a database setup. Okay, now you know to do that database setup. You can do it later. I will ask the team to upload a video for setting up the database on Monday morning. You follow that and do it. Very simple steps. Follow that and do it. If you have any problem, I'll help you out later. But that is not a prerequisite for now, because we are going to start with only the login transaction today and tomorrow. Okay, for doing a login transaction, you no need to have a database. Okay, fine. So from a setup perspective, we'll keep it very simple. You have your Java configured in your machine, and then download the Tomcat, and then start the Tomcat, and then you will be able to access this URL, and then you should be able to do a login. Okay, these very simple step, you should be able to complete it in a very 5-6 minutes. You should be done with this. Okay, fine. Now, just give me a few seconds. We'll take some water. Anybody have any questions on this? Raise your hand or unmute, ask. Even if it's a silly question, don't hesitate. Please ask.
Satish, I shared a screenshot, like I was not able to log into the admin, the application. I was not seeing anything. So should I also do this new Tomcat and then try?
Yeah, try it out. Try it out. Please try it out. Yeah. Try it out. If you guys still have a problem, we will sort it out tomorrow during the daytime. Don't worry. Before the session starts tomorrow, we will sort out these problems. But yeah, you try it out with this new file. Okay. Anyone else have any other questions on this setup? No problem. Okay. Fine. So let me go and open up. Just give me 1 second. Yeah, okay, fine. Now, from the performance engineering perspective, um, as I was saying the other day, right, there are multiple things throughout the SDLC cycle we will be doing it. Okay. Now, one of the important thing is, before we go into the testing phase, during the development, we have to work with the developers, take the functionalities that is getting completed. It can be a web service, it can be a UI functionality, and then our objective is to make sure that response time is optimized, the memory is optimized for that particular transaction, particular functionality with a single user. For a single user, we have to make sure the response time is optimized, your memory is optimized. That's a goal of a performance engineer early in the life cycle before we go to a testing. Okay, that's the first responsibility of a performance engineer. Okay, uh, we don't want to be reactive. We run a load test and we find a problem, and then you debug it, you find out the root cause, and then a developer going in and fixing it. It's a costlier operation. Okay, so the responsibility of a performance engineer is to proactively look into the um, performance issue and find out problems early in the life cycle. So we will assume that we are a performance engineer in a project, and then we are going to work on a e-library application. A login functionality is deployed, and then we are going to troubleshoot the login problem. Okay, so for that, what I will do is, um, let me go and download the war file from yeah, let me download this okay, okay, let me not do this. Let me go to the response time issue itself. Response time analysis. No worries. Let's continue with the same war file, whatever we have it. Okay. Um, the way we will address this response time problem is these 8 steps. Okay, not a problem. Analyzing the response time, right? For a given functionality, we will go and follow this 8 steps one by one, as part of a process. Okay, number one is validating your browser load time, and if the load time is more, we'll go and check which resource is consuming more response time, and then we'll go and check the time to first byte and download time, and then we'll go and check the Tomcat access log to verify whether the issue is with the server side. The response time is also high in the access log. Then we have to go to the profiling. Okay, so the way it works is, as an end user, okay, as an end user, you will go and access your functionality from your browser. And in the browser, when you look into the network tab, when I say network tab, in the developer tool, okay, Control Shift I, or if you go to the tools, and then if you go to the uh, your developer tool, right, Control Shift I, you'll get this you'll get this window, and go to the network tab. Okay, so when I do this login, you'll get all the network calls, all the API calls or HTML pages, whatever that is getting loaded, you will see it here. Okay, it has admin login, it has CSS, it has JavaScript, it has images, it has fonts. All these combined is the your admin login page. Okay, so note down the load time. Load time will appear in the rightmost, bottom rightmost. Okay, this load time 6.43 seconds. you can just assume that um, when you click something, and if you go to the next page, a complete loading of a page is your load time. Okay, otherwise you will have a spinner, right? If I go to say crickinfo.com, your things get spinned, right? And then the page will get loaded. The time that takes to load the page until the spinner stops is your load time. I don't know why this crickinfo is taking more time. Let me go to ndtv.com. Okay, so the moment the page loads and the spinner stops, if you see that in the top a spinner will be there, right? That spinner stops, that's visually that is called a load time. Okay, you can just, there are formulas for that, I'll talk about it later in the client side performance. But this load time is nothing but when you do something, a page comes properly and you could able to see it as a load time. So load is 6.43 seconds for the login. Okay, 6 seconds is higher only, right? Our SLA would be normally 3 seconds or 5 seconds. Depending upon the business, depending upon the product owner, they will define the SLA. They will say that login has to be completed in 3 seconds or 2 seconds or 4 seconds or 5 seconds. Maximum it is 5 seconds. So 6 seconds is more. But when you do this profiling, when you do this response time analysis, don't look for one sample. Okay, so when you start the Tomcat server and then you do the first navigation, it might be a little slow. So don't consider that first login. Okay, just do couple of logins, two times, 3 times, 4 times. Okay, clear the log. Okay, and then I'll just do a log out. If you do this clear, it will clear it. Okay, and also there's something called disable cache. Turn on this. I will tell about what is cache later. Okay, but just blindly follow this. I'll explain this caching and all when you go to the client side performance. Okay, don't worry. So turn on this, disabling the cache, and then do a login again. Okay, so when you do this time it is 4.276 seconds. Okay, 4.27. Again do a logout. Okay, clear it. Again do a login. This time it is 4.33 seconds. Again I'll do a logout. Again I'll do a login. Okay, so it's around 4 to 5 seconds is the response time. Right, now your SLA could be 3 seconds, it can be 5 seconds, it depends. Okay, let's assume that your SLA is 3 seconds now. Okay, so your response time for one user is 4.5 seconds, around 4.5 seconds, which is not acceptable. Now you have to go to the second step. Okay, so let's check the resource which is consuming more time. When I say resource, in your admin section you have these many resources, correct? You have admin login, HTML page, your style sheet, your images. So in that, if you see, if I expand this, you see the time at the right hand side. Okay, so there you see admin login has 4 seconds, style sheet is taking 71 milliseconds, 181, 244, 59, 140. So out of all these resources, first admin login document, HTML document, took almost maximum of the time was spent in this admin login. Okay, 4.07. Now, so out of this 9 resource, this is the culprit, 4 seconds. So click this admin login. Oops. Okay, one second. I think I've done something. Yeah, go to the timing. Okay, so I'll do it again in the admin login. Okay, if you go to this 4.07 seconds, click this admin login. Click this admin login. This thing will get loaded, and then go to the timing. Okay, in the timing, you will see that request sent from a browser to server, it took 0.25 milliseconds. From waiting for server response is your time to first byte. Okay, what it means is from a browser you sent a request for login. So from a browser to server it took 0.25 milliseconds, and your server will do the processing, right? It will go and check in the DB, or it might go to some it will do a single sign-on validation, or it can go to an LDAP. So it will go and check your with the user ID and password. It will go and validate, and then it will send the confirmation saying that login is successful, and it will give the home page. It when the entire page or entire response, it won't be sent in a single shot. It will be always response from a server to browser. It will always be in the network packets. Okay, the entire this HTML page, even though it is size is if you see the size, it is 2.7 KB. The entire 2.7 KB will not come in a single shot. It will be split into a multiple packets. Okay, so time to first byte, what it means is when a first byte reaches your browser, server completes the processing and it will start sending the response. When the first byte is received from by the browser, that time is called time to first byte. That is a indication of how much time your server took for processing. When time to first byte is high, most of the time it might be because your server is taking more time to process the your functionality, to execute your algorithm. And this content download is difference between time to first byte and time to last byte. So it will take time to download the entire content, right? From 1 byte to 10 KB or 20 KB, it will take some time to get downloaded from a server to your browser. So this content download is nothing but time taken for between time to first byte and time to last byte. Okay, so for every resource, for a style sheet, for an image, for your API calls, for your HTML page, either time can be taken in consumed in the waiting for server response, which is a time to first byte, and then it can be consumed in the content download, either of the way. General pattern is for your HTML page, for your API calls, usually time to first byte will be more. Okay, because that's algorithm will be involved, right? For any APIs, for any HTML documents, there will be algorithm that will be involved. So time to first byte will be more, but the content size will be always less. It will be in bytes or KBs. So it will download immediately. But all the images, JavaScript, style sheet, and all, there's nothing to process. Your server is not going to process any algorithm. So time to first byte will be very fast, but content download will be comparatively more. For example, if I take this admin image, time to first byte is 27 milliseconds, whereas content download is 132 milliseconds. Same if you go to style sheet, right? Um, Style sheet is almost both are same. If you go to another admin image, 27 milliseconds and 197 milliseconds, right? So usual pattern is your resources, your images, JavaScript, style sheet, and all. It'll be more in content download, but your dynamic processing, your HTML document and your APIs, time to first byte will be more. Okay, so now coming back to our analysis. Okay, so step 2 is check the resource which consumes high response time. This time for us it is this HTML document. That took more time. And then third step is check your time to first byte and download time. Check both, which is taking more time. Here, of course, time to first byte is the one which is taking more time, which is 4 seconds. Okay. Now, as I said, mostly when I see time to first byte is taking more time, it means your server is taking more time. Mostly. Okay. To validate that, so you cannot blame that there's a problem with the server side code. When you say server, it's a server side code. It's a problem with your code. Somewhere, some problem with your application code. To confirm that, the next important step is to check your logs. Check your server logs. Okay. See, when you do this profiling, when you do this analysis, right, you should remember that you should have a dedicated environment for you for profiling. Okay. Don't use performance environment or QA environment or development environment. You get your own machine. It could be a Linux machine or it could be Windows machine. One machine in which you can deploy your application. Okay. So that you will have access to check the logs, restart the server, make some configuration change. All these things you should be able to do it, because you are doing a profiling. We cannot expect another team to go and restart the machines, apply some configuration changes, um, to check the log. All these things you cannot rely on others. You have to do it by yourself. So whenever in a project, for a profiling, maybe not immediately, right? Once you gain enough knowledge, when you're going to use this in your project, that is going to be one of the prerequisite. You should have a dedicated machine for your profiling. You should have the application server deployed, your application war file deployed, and you should be able to restart the application server the way I'm doing it here, right? I go here, I can able to restart my Tomcat, right? And I can go to logs, I can open the log and I can look into the logs, and I can go to the Catalina file and then go to the bin folder. I can go and change the heap or apply some other configuration changes. All these things I should be able to do it. Similarly, in the project also, you should be able to do it. Okay, you cannot do it in the performance environment or QA environment, because it's a controlled environment. Other people also will be using it. So for your profiling, you should have a dedicated machine for sure, where you will have install the Tomcat or a JBoss or a WebLogic, and the war file will be deployed. Okay, remember that. Okay, now verify the access log for the response time. So access log is a very important log in a web server, which is going to um, um, have all the information related to what request is coming in. Okay, and yeah, this localhost access log, there will be access log created. Open it in the notepad. It will have all the requests that is coming in, what time it came in, what is the URL, what is the response code, what is the response size, and what is the response time. All this data you will have it in the access log. So if you come down in the access log at the last, okay, if you check for login, /up, if you go up, last admin login, yeah, /admin login, right here, it took 4067 milliseconds. The last one is a time. I'll tomorrow I'll explain you how to read this access log file, because everything has a meaning. This is the timestamp, this is the method, this is that again the URL, this is the HTTP method, response code, response size, and the response time. Okay, so this access log configuration will be there in a Tomcat folder. I will tell you later. Let's not confuse that. Okay, but this access log will have the last two things will be your URL, and your response time. Okay, so whatever we saw it in the developer tool, it matches with the server side response time also. Here I see my admin login took 4.07 seconds, and here it is 4067 milliseconds, which is 4.067. 4067, and here it is 4.07. Okay, both are same. Okay, so this is in milliseconds and this is in a second, so it is 4067 milliseconds. So which means I'm ensuring that whatever I see it in the browser is what I see it in the server side also, which means definitely it is consuming 4 seconds at the application code level. That's a confirmation you have to get it before you go to the further analysis or code profiling. Before we go and do a code profiling using JProfiler or any other profiling tool, we have to ensure this from step 1 to step 5. You have to do it, checking the load time, checking the resource which is taking more time, checking the time to first byte and download time, and then verifying it in the access log. And only if these access log says that your response time is similar to what you see it in the developer tool, then we will go for the profiling. In case if you see that in the browser you see 4 seconds, but in the Tomcat log if you see 1.5 second, 2 seconds, then it's not a code problem. This will not, this log will not give a false statement. This will be accurate always. Okay, in that case, see, generally problem could be, one could be a network, uh, one could be network where you will be accessing the UI from one machine. Okay, and then your profile, your application is installed in another machine. There's a latency between two machines. That could be one problem. Second is, um, there are too many things that is running in your machines when you do a profiling and all. Okay, both in the profiling, both in the server machine and also from where you open this UI, in both the machines you should not have unnecessary things running. It should be very clean. Only you should have a browser and in your laptop or in your testing machine, and in the server machine you should have only that application running. Okay, so if you see that your access log is showing lesser time, then just do a restart and then close everything and then test it out without any other noise. That's very, very important when you do a profiling. So like in my machine I have multiple tabs open, right? Don't keep unnecessary tabs. Close all your Outlook, everything, right? That's why for testing also you should not do a testing from your laptop or from your workstation. You should again have a dedicated machine for your testing also. Okay, similar to your load generator, get a one dedicated machine for your testing, and from that you open the Chrome and test it, because when you open it in the UI and do all this navigation, it's very sensitive. If your laptop is slow, if your machine is slow, or if you open too many tabs, then also whatever response time you see here, it might not be accurate. So as a good practice, recommended option is you get um, two machines, one for your testing and installing your testing tools like JProfiler, JConsole, your browser. You will have one testing machine for profiling. Second is going to be your one more machine for your server, where you can deploy the application. Okay, so in your project, the recommendation is, a prerequisite is, for doing this engineering activity, one, get a dedicated machine for your testing and testing tools, and another machine for your installing your Tomcat or JBoss, and then your actual application warfile. Okay, without that, if you do it, you will end up with a lot of confusion. You will not be able to conclude anything at all. Okay, don't compromise with doing something from your laptop or your workstation. Unnecessary noise will be there from other applications, other softwares, which will lead to a lot of confusions. Okay, so don't ever do it, don't ever compromise it. Okay, so after following all these steps, then we'll go for the code profiling. Okay, I'll pass it here. Um, Anybody have any questions on why are we doing this, or any question on how to do this, whatever we have done so far? Um, Please ask, guys. Anyone have any questions?
Yes. How we can transition from existing like performance testing role to this performance engineering role in an existing um, project? I mean, if there is not this requirement, ho- but but how can I pitch to my client? And also, as you are saying, uh, there there should be a dedicated machine for doing the profiling. Those kind of budgeting and all those things will not be, answered
Yeah,
immediately,
yeah,
or can
true,
be
true.
provided, right?
Yeah, yeah. See, there are going to be projects where the
And
customer will expect you to do these analysis, this profiling engineering. There, I think it is little easy. Once you have that enough knowledge and experience, you can say that you will be able to do it. And then, since they are asking you to do it, they will provide all the required infrastructure and prerequisite, right?
mostly it is overlapping with the development teams work as well, right? Their task.
No, it is not a over. See, these profiling can be done by the development team also. Um
Yes.
it depends upon what is the scope, right? Um, Assuming that your developer is not going to do it, okay, because all these are all extension of testing, okay. Um, when there's a requirement, some customer saying that the performance testing team has to do all these things, then you can provide this prerequisite and requirements, and they will give it. But wherever you're going to pitch in, say in a project, and you are a performance tester, you're doing all the scripting execution, and now you know that how to do it, then you can go and tell your customer that, saying that we have this capability to do extra engineering, extra profiling, and we would like to do it, and give me this infrastructure. If they don't give it, we will not be able to do it, right? If customer will, most of the time customer will be happy to do it when you're going to come up with these recommendations, or you're willing to do extra things, right? Obviously there are effort, right? You If you are only one person, and if you wanted to handle all the scripting execution, and this engineering thing is going to be an overhead for you. Again, when you're going to commit you have to look into the effort also, whether you will have enough bandwidth, you have enough people, or if you want to include one more performance tester, and then you are going to engineering. So all these things will come into picture for sure, effort, timeline and all, okay. But provided you have a bandwidth, then you can go and commit. And then, while you saying that you will be able to do it, they also have to provide you tools and infrastructure. So anything is not going to come without a cost, right? You need tools, you need infrastructure. Along with that, they are also going to get a proper analysis, observations and recommendation. So that's how it works. It's not something you're going to ask it for your personal work, right? You're going to ask it only for project work. So you provide your expectation properly, and then say that with this I'll be able to provide the additional observations or recommendation, and it's a customer to take the decision.
Okay. Additional observations. Yeah, that's a good point. Yeah. Okay.
Yeah, yeah,
I
yeah,
mean,
yeah, yes.
added
Yeah.
advantage for them.
And the problem is, if we don't do these things now, if we don't reduce the response time, if we don't arrest your memory leaks, then if you go into a testing execution directly, there you will have a problem. Then you will have time to go and fix it. Developer will not have time to fix it. Your deployment will be delayed. Your production will be delayed. That is the major benefit of doing this early performance engineering. Okay, that the customer has to understand, and they will understand if most of them will understand.
and and this is totally different from early performance testing, right?
This is
This
early
is
performance engineering. Okay, an
this is
early
this
performance
is
testing.
engineering, and
It's a
yeah,
engineering.
okay.
Yeah. See, in early
And
performance testing, what you do,
more
you might be like testing it
more
with
sort
50
of
users or 100 users, right? Early performance testing
correct,
is, yeah, that's how. Here it is an early performance engineering.
more sort of static analysis.
It's not
kind of.
static analysis. It's not static. It is a single user analysis. You call it. You can
Okay.
call it as a single user analysis or a profiling, right? But it's not a static because it is a dynamic only, right? You're accessing your application. You're doing a login. It's a dynamic only.
Okay. Okay. I mean, sometimes we can just say by looking into the configuration also, right?
Both, yeah. See, it is,
That will
so
be
it's not
static.
only, it's not a static. It is combination of both your configuration and your code. So it is in that way. It is dynamic in nature.
Okay, I got it. Thank you.
No problem. Rajita, you have
Yeah,
any question? Yeah, yeah, go
uh,
ahead.
yeah. Actually, Satish, so will you be able to provide any points for the prerequisites of this early performance engineering?
Okay, I can probably create a checklist and then share it in the drive.
Okay, yeah. Thank you, Satish. And also,
Sure.
so I had experience in performance testing. So, but for this early performance engineering, we'll not be doing any scripting. This is the main
Yeah,
agenda
yeah,
of this is like to get the
correct,
performance reduced at the early stage itself.
correct,
Okay.
correct, correct, correct. You're right.
Okay, so after everything is, I mean, after all these steps are taken, then in the in the end step, we'll be doing scripting and then providing the results with the performance testing.
Yeah, that can happen parallelly also. As a application is getting developed, you do engineering, you also go and create a script for login, and then you might be running it for say 10 users or 100 users as
Yeah.
part of a component level testing. So both will go hand in hand, early performance testing and this engineering will go hand in hand.
Okay, so this is like purely how can we call this role like performance engineering or performance test engineer?
This is engineering only, purely engineering.
Okay, okay,
Yeah,
yeah, got it. Yeah, thank you, Satish.
sure, sure, no problem. And I'll start the recording.